Hello, welcome all to my channel. Today we are carrying our discussion with types of DBMS. Moving towards the actual discussion, I would like to introduce one another characteristics of the DBMS, that is data models. As the data DBMS contains a very huge and the complex kind of data, and we have already seen that this data is interrelated with each other. So the process of analysis of these data objects and their relationship is nothing but called as a data modeling. Whenever this kind of a relationship we are trying to represent conceptually in a graphical format, in a diagrammatical format, that is called as a data models. The data model is the first step of the database designing. It is one kind of the abstract model that organizes all the elements of the data in a particular format. They are also deciding the method of storing of a data in that database, and also how it is going to be managed. That is also decided with the help of data models. Data model defines how the data is connected to each other and how they are processed and also stored inside the system. These data models provides the way to describe the design of the database at physical, logical, and view level. In short, we can say that it is a tool developed to summarize the description of the database. So, all the database designing is summarized in a graphical, in a diagrammatical format with the help of data models. There are different data models present in a DBMS, that is relational, hierarchical, network-based, entity relationship model, or object-oriented model. Based on which model adopted for the creation of that DBMS, DBMS is going to be differentiated into 4 different types as hierarchical database, network database, relational database, and ER, entity relational database. Let's see one by one. The first one is nothing but the hierarchical database. This one is the oldest and the straightforward kind of a representation. In the database, this one is called as an hierarchical model because the hierarchy in the database is going to be maintained. This model, this is the model in which data is organized into a tree kind of a structure, and that's why it is called as a hierarchical DBMS. This structure contains a parent-child relationship where the root of a tree is nothing but called as a parent node, and the branches of a tree is called as the child node. That means here the parent-child association between the different records at the different level is carried out. And that's why due to this kind of a structure, the data integrity is achieved. As here, the data representation is carried out in a very easy way. It is the performance of this system is very efficient. It is very easy to understand because in a straightforward way, we are maintaining the relationship. Here, all the data is stored in a form of records, and these records are connected with each other. For example, let's consider this one is in a college database. This one is the main, you can say the root of a tree, or this is a parent having 2 child, that is department infrastructure. The department having different criteria, that is a course, teacher, student. A course having the 2 parameters, that is theory and lab. So you can say that there is a one parent, there are the many number of children, but one children having only one parent. That means in hierarchical model, there is a business rule. The rule is that one parent node have many children node, but one child node have only one parent node. That's why most probably this one is used where the straightforward kind of an information is available in a database. It is the oldest kind of a data model adopted in that particular database. So this one is all summarized over here. Data is represented using a parent-child relationship. In most of the DBMS, we can be moving with a top to down kind of a format. Here, the parent may have many children, but the children have only one parent. That is the restriction, you can say, or the drawback of the hierarchical model. And hence, to overcome this one, we are moving towards the next type of the DBMS, that is called as a network database model. You can say this is the extended type of a hierarchical model. The data model is same thing we are carried out as in a hierarchical, but the very important parameter over here is that any child in a tree can have a multiple parents also. That is not available in the hierarchical. That drawback is overcome in a network. That is, as just shown over here in a diagram, the college having the two criteria. One is department and the library. And there is another thing, that is a student, that is a child from this department as well as in the library. So you can say that this student kind of an entity having the two parents, department as in a library. So in this way, we are forming some kind of a network between all these entities, and that's why its capability, this kind of a database is able to handle the various relationship, because here it can be handled one to many and many to many relationship, which one is very useful for development of the database. And due to this one, it is very easy to access and flexible than the hierarchical data model. So here the network database allows one child to have the multiple parents. It can be followed many to many relationship. Hierarchical model is just from many to one to many kind of a relationship. That's it. But here many to many relationship is possible. In this database, the entities are organized in a graph which can be accessed through the several paths. So this graph, why it is formed graph? Because we have to go with a many to many relationship. And due to this, the tracing of the relationship is very easily possible with the help of a network DBMS. Another point, next type of a DBMS is the relational DBMS. This is the DBMS which is most widely used because it is one of the very easiest. It is an attempt to simplify the data structure by making the use of a table. All the data over here is organized in a two-dimensional format, that is in a table, and the relationship is maintained by storing a common field. I will come to this point in detail. That means in the point that we have to remember in a relational DBMS is that it uses the table for representing all the data and the in-between relationship. Table represent both the data as well as the relationship. As we know that table is the combination of rows and columns. That means one kind of the word relationship over here used is a very important. Whatever the data is stored, that has some kind of a relationship between them, and that's why it is called as a relational database. It is also called as a record-based DBMS because each record type defines a fixed number of fields or the attributes. It is most widely used data model available and most popular in different types of the DBMS. In this type of DBMS, as I have told you that all the data is represented in a form of a table. This table, in somehow, we can be called it as a relation, and that's why it is called as a relational database. So, it is called as a relational database management system, that is RDBMS. So, this RDBMS is the collection of the many databases. Each database consists of many tables. Each table is nothing but consists of the different kinds of fields, and the group of this field is called as the record. In this kind of a relationship is maintained in this type of DBMS. That's why It is very, very useful for the accessing of the data. So all this one I have just mentioned over here. The basic structure of the data in the relational model is nothing but called as a table. It uses the collection of table for representing the data and just relationship among them. Data is stored in a table that is called as a relation. Here, the column, the table, or or you can say the relation is nothing but a combination of rows and columns, where the column represents the attribute of an entity and row represents the record, or also called as a tuple. For example, if any of the data, if there is a database where the information is related with a student's roll number, first name, last name, etc. So these are the characteristics of the student. So you can say that the roll number, first name, last name, these are the attributes of the student entity. Student is a one person. That person having some of the characteristics. So that person is called as an entity, that object is called as an entity, and its characteristics are called as an attributes. And another important thing over here is nothing but an tuple or the record. That means you can say that there are the three, any of the table having its attributes and the, or you can say the columns, and the rows are also called as the records or the tuples. Each row in the relational is called as the tuple. Tuple or the row defines the collection of attributes values. For example, I have just considered over here is a table. Now we are calling it as a relation. This relation having the different kinds of an attributes, that means columns. Which are these columns? Columns are also called as an fields. Rows may be called as the records or the tuples. So these columns or attributes or the fields are student ID, name, login, age, and gross marks. These are the columns, or you can say the attributes. The attributes having different kinds of values, that is 1111 Dave at CS 191.2. So these all row, the row defines the collection of attributes. These attributes is defined, represented with the help of one row, and this one row is called as a tuple. So in this way, the relationship between the different objects in a database is going to be represented over here, and that's why it is called as relational DBMS. This is the another way. So in a first way, I just see that there is one common field through which you can be access the data. This is one table, this is the another table. Here the student information is carried out. Here the subject information is stored. And from these two tables, I have just creating one another table, putting down some relationship, that is student ID 1 is taken out the subject 1 having marks as a 98. The same student is also moving towards the subject number 2, which is having the 78 marks. So the student ID taken from this table, the subject ID is taken from this table, and the particular marks for that student for the different subjects is created in this table. So we are putting down the relationship from this to this and creating some another table which gives me the mark of a particular student for the particular subject. In this way, the relationship established. Nextly, the another very, very important database is nothing but entity relationship database. This database is based on the ER model, which is a very high-level data model. This database is explained with the help of a diagram, which is known as the entity relationship diagram. As in a C programming language, we are using the flowchart. Within the flowchart, we are using the different diagram shapes for representing the different actions. The similar way, the different kinds of entities, we are going to be considered diagrams, their shapes are considered for the creation of the ER diagram. We will be just seeing this in detail for the next lecture. But that kind of a diagrammatical representation is carried out in this database. This entity relationship diagram or the ER diagram consists of mainly three components, that is First is the entity. What is this entity? Entity, you can say that it is the any real any kind of a real world thing or the object. It may be a person, place, or concept, whatever it is, which is present right now. That is nothing but called as an entity. For example, student, teacher, department, courses, employees, company. These are nothing but the sum of the example of the entities. Their database may be a different. The one which one is available right now, which one is an a real, it may be a object, it may be a place, it may be a person, whatever it is nothing but called as an entity. Second is nothing but an attribute. Attribute means that person is having some kind of an characteristics, that object having some its specialized highlighting features. That is nothing but called as an attribute. So any of the entity contains some of the real world property, that is called as an attribute. For example, a student, that is a one person. It is having its own characteristics. It is that particular student having particular roll number, its first name, last name, their marks is going to be varied. So all these are nothing but an attributes of the student entity. And the very, very important thing is that whenever we are creating the database, we have to be put down the relationship. So the relationship is the way or the relation through which we are two attributes are connecting or related with each other. For example, if there is a teacher and the department, these are the two attributes, then we can say that teacher works for the department. So this works for is nothing but called as a relationship. A teacher and the department, they are going to be related with working kind of an action, that is called as a relationship. A set of same type of an entity is called as an entity set, and the set of same type of an relationship is called as a relationship set. So this is one kind of the ER model where the entities and the attributes are there. Some kind of an special features or the figures are used to represent the entities and the attributes. Teacher and the department, these are the entities which are represented with a rectangle, and their attributes, that is ID, name, mobile number, salary, age, these are used with some kind of an oval shaped structure. They are going to be interrelated. They are with the some kind of a criteria that is in a works for. This relationship is going to be represented with this diamond shaped structure. So in this way, with this kind of a specified structures, we are putting down the relationship. And with the help of this grammatical in a figure kind of an representation, we will be get the idea of database, the relationship between the different entities used in the database. So this one is all about for the today's session. Thank you.